to, yay, score a microphone from Mr. Carl. So when I'm sitting at my desk, you should be able to hear me without any issues with the sound. So off we go. Alright, so yesterday's lesson we talked about finding unknowns in our equations, and today we're looking at distance and time. So we looked at story problems that involved formulas. We had area, circumference, and volume, and now we're going to talk about distance, rate, and time. And this is the formula: distance over rate equals time. So we're going to call this the distance formula, okay? And it can be used to figure out three different things: how fast something traveled, how far it traveled, and how long it took to get there. And as long as we know at least two of these variables, we can figure out the third number with this formula, which was the whole point of this lesson, okay? So we're going to shorten it, and they've done this here, to distance d over r, or d divided by r, equals t. Okay, and that's the same thing that we've been doing. We know that that symbol right there, it looks like a fraction symbol, but we know that that is a division symbol in mathematics. And we know that we have to substitute our numbers in for distance, rate, or time, and by doing so we can essentially find out the answer for our problem or for whatever we are trying to solve for. And they've given us a little sample where if we divide 15 by 5, we do get an answer of 3. So again, we are looking at just plugging in numbers and then solving for whatever variable we do not have. Alright, page 17. And it doesn't matter if we switch our numbers. On the other page, it was 15 divided by 5 is 3, and we know that 15 divided by 3 is 5. So these two numbers are interchangeable. If we know one, we can find the other, and if we know the other, we can find the one. And we use them both together to find the distance. Okay? So as is many applications in not just algebra, but in math in general, the numbers are interchangeable. We know that we are working on the inverse operations. The inverse operations of multiplication is division, and the inverse operation of division is multiplication. So we have the word distance, and it is always, if here, is always divided by either the rate or the time. Okay? So you can say, as we know, interchangeable, inverse operations, distance divided by rate equals time, or distance divided by time equals rate. Either one is correct. We just have to be sure to start with the word distance and then divide the rate by either rate or time. Okay? And if you want, you can read the rest of that page, but essentially what we're looking for is to solve for one of the missing variables. Alright, so we're going to look in this section here, and it says, let's say you drove a car at the same rate of speed for an hour. After 1 hour, you had traveled 60 miles. Was that the speed of the car? No. Distance is how far you traveled, and the distance is how many miles, right? And it took 1 hour to travel 60 miles. So if I want to find out how fast I drove, right, then I would substitute, this is distance, right, and then this is rate, or time, time, and then this is the rate. Okay, so if I drove for an hour at 60 miles an hour and I'm going to divide 60 by 1, then I know that my average rate of speed, 60 miles per hour, is the average rate of speed that I traveled. Okay? Now we can do this with just about any calculation. You know that I spend an hour on my drive to work every day. And I travel exactly, oops, sorry, it's the other way. 60, and I drive 27 miles. Okay, or we could say that I drive 1 hour, right? And I drive 27 miles from my driveway to the school's driveway. Well, I could divide that by 60, right? But it's still essentially saying that I've driven 1 hour. So what's my average rate of speed? Well, 27 miles per hour, which seems really, really, really low. But when you take into consideration how many streetlights that I stop at and all of the slow people that are around me when they're driving, that is essentially about the average rate of speed that I take to go to and from work. And I've never actually calculated that, and that's really, really, really low. So anyway, but that's how we figured it out. Now, we've got another question here. How long will it take a train to travel 300 miles if it is going 80 miles per hour? So again, we have the distance, which is 300 miles, divided by the rate, which is 80 miles per hour. And if we do this, we find our answer to time. And I'm going to move to the next page because they've done this for us. And again, we all know that we can cross cancel. So this would be 30 divided by 8, and it is approximately or equal to 3.75 hours. So it took 3 3/4 hours for that train to travel 300 miles at a rate of 80 miles per hour. And here we go is another one. How fast did Courtney drive home in the snow? She traveled 10 miles, but it took her 2.5 hours. Okay? We know from what we've just learned that we can substitute these. These are interchangeable. And so what I'm going to do is substitute this 2.5 as my division. So now we have 10 divided by 2.5 to find out the rate of speed. And I'm going to go to page 20 at the top. And if I divide 10 by 2.5, that gives me 4 miles per hour. She traveled a lot slower than I did, but we were still able to find out how many miles per hour that she drove. Okay? So now we're going to look at solving for the distance part of our formula. And the question reads, a cougar was seen running at 40 miles per hour. He continued to run at that speed for 15 minutes. How far did he get? So we have the speed and we have the minutes, but we don't know, right, how far he got, which was our distance. So we can write 15 minutes as 0.25 or 25% or 1/4 of an hour, right? Because it's 1/4 of an hour, we know that the fraction is 1/4 and the decimal is 0.25. And so now what we can do is we can turn this into a multiplication problem. And this becomes 40 times 2.5. Okay? And going on to page 21. When I multiply 0.25 times 40, I get a distance of 10 miles, right? So the cougar ran for 2 miles, 10 miles. Again, if you have any questions or if you need to pause the video, you are in control, my friends. And now we're going to go to page 22. It took 3 hours for the airplane to travel 1,800 miles. What was the airplane's rate of speed? So, if we were going to set this up, we have distance over time equals the rate. And right now, we don't know what the average rate was. So we're going to put 1,800, and the time was 3 hours, equals R. And if we divide 1,800 divided by 3, well, 18 divided by 3 is 6, and we have to add our zeros. So the airplane's average rate of speed was 600 miles per hour. It was a really fast airplane. Okay? Now you guys are going to complete the rest of the worksheet for classwork, and then you're going to turn it in and submit it. And your homework is also attached to this lesson segment. As always, if you have any questions or concerns, guys, let me know. I am available. That's what I'm here for. And I will see you